Let us discuss BFS algorithm now. BFS is implemented using queue. That is, each time a vertex is visited, it is inserted into queue. As all of you know, queue will be inserted from the rear end and item will be deleted from the front end. So now we will take a queue. I will just draw a queue something like this. So let me start with the vertex A. A is the first vertex being visited and I will mark it as 1. Now, for A, there are two vertices connected which are C and B. Both of them have to be visited together. So, because it is a breadth first search, breadth, that means for A, breadth wise there are two nodes, that is C and B, both have to be visited. So now, I can take either CB or I can do BD, whatever. So let me take C is the second vertex, B is the third vertex to be inserted into the queue. Now, since deletion should happen from the front end, this would have been front end till now, and now A will be deleted. So after deleting A, front would be C. Now we have to check any vertices which are connected to C. So for C, the connected vertices are E, F and D. So now all the three have to be inserted into the queue one after the other. So in any order I can choose either E first, F next and D next, or D first, E next, F next, whatever. However the order you want, you can just insert it. So let me take E as the fourth vertex, then F as the fifth vertex and D as the sixth vertex to be inserted into the queue. Now, after that, C has been already deleted from the queue. Now, front of the queue will be B. Check whether B has any other unvisited vertex. No. So, hence B has to be deleted from the queue. Now, check front of the queue, which is now E. Again, check for whether E has any unvisited vertex. It is not there. So, you have to delete it. Then again, you will get F. Again, F will be deleted and D will be deleted. Note that in BFS algorithm, we will be putting only the one index, that is insertion index, but not deletion, because deletion always happens from the front end in the queue. That is why we are going to use only one index, that is insertion index. Whereas in the DFS algorithm, we have used two indices, one for insertion and one for deletion. That is one for pushing up and one for popping from the stack. Now it is a queue, so deletion will be always from the front end. Now, for this DFS trace, let us draw the BFS tree. So let me start with A, first vertex which has been visited. Then for A, we have visited both C and B together. So we have to draw something like this, C and B. Then for C, we have visited E, F and D all together. So that is E has been visited, F has been visited. Immediately after that, D has been visited. Now note down the graph. B and D were connected, so put a dotted line something like this. So now, this particular straight lines are called as tree edges and dotted lines are called as cross edges. So this is BFS Traversal. Just like DFS, there will be multiple options or multiple solutions for BFS algorithm as well. That means instead of starting with A, if I would have started with D, my solution would have been different. Say for example, I will take another queue as another example. Say for example, if I started with D as the first vertex, D would have been first. Then for D, I have B and C connected. So let me write B first and then write C. Then after inserting B and C into the queue, D would have been deleted. Then B will be front of the queue, and for B only one vertex which is connected is A, so A would have been the next one. Now after that B would have been deleted from the queue. Now C will be the front. For C connected vertices are E and F. So E as the fifth vertex, F as the sixth vertex. So now after that C will be removed from the queue. A will be now front. A do not have any other vertices connected to it. So A will be removed from the queue. Then E will be removed. Then F will be removed. So our BFS traversal would be D, B, C, A, E, F. So earlier I had A, C, B, E, F and D. So whichever way you want you can solve it. Normally just like DFS algorithm, any undirected graph can have multiple solutions if you traverse it using BFS traversal.